All right, so in this video, we're going to be looking at solving two simple modulus equations or equations involving modulus. All right, the first one we're going to look at has a modulus on the left side and something else on the right side. Now remember, if you get an equation with a modulus and other things, it is best to isolate the modulus. So transpose and get the modulus on one side. That has already been done for us. That's fine. We don't need to do anything as it pertains to transposing. So we're going to go ahead and solve. To solve something like this now, very, very simple. We're going to take what's in the modulus and you're going to equate it to what you have on the other side, right? To form an equation. And then you're also going to form another equation. You're going to take what's in the modulus again and equate it to the negative of what's on the other side. So in this case, negative 53. And then we're going to go ahead and solve them individually for x. So let's start with the first one. This is 8x equals 53 minus 5. That would be 48. And then x is equal to 48 divided by 8. That's 6. And so we get a value for x as 6. For the second equation, 8x is equal to negative 53 minus 5, which is negative 58. And then x would be equal to negative 58 over 8, which we can break down into 28 4. 2058 is going to give us 29. And so we end up with negative 29 over 4. And then, so those are our two x values. It would also be good, however, to check to make sure your values work. All right, so this is our check. We're going to take the x as 6 and we're going to plug it in here. So we're going to have the modulus of, this is going to be 6 eighths 48 plus 5 53. So this is the modulus of 53 equals 53. And we know the modulus of 53 is equal to 53. And so it works, right? This value works. We're going to check this one also. So we're going to take the negative 29 over 4 and we're going to plug it in for the x here. So we're going to have, let me write this one out. We're going to have the modulus of 5 plus 8 times negative 29 over 4 equals 53. 4 into 4, 1. 4 into 8, 2. This is going to be 5 minus 58. And 5 minus 58 is negative 53. So what we have here is the modulus of negative 53. And we know that the modulus of negative 53 gives us 53. So 53 equals 53. And this works also. So we have two solutions for x. X is equal to 6 and x is equal to negative 29 over 4. Let's look at another example. This example involves two modulus. So if you have, in this case, modulus 5x plus 3 equals modulus 2x minus 1, the approach is similar. You're going to take what's inside of any one of the modulus. It doesn't matter which one. So let me use the one on the left. And you're going to equate it to what's inside the other modulus to form an equation. You're also going to do the same thing in terms of take the 5x plus 3, but this time you're going to equate it to the negative of what's inside the other modulus, right? Just like we did with the first example. 53, negative 53. Something similar. 2x minus 1, the negative of 2x minus 1. And then we go ahead and solve individually. So 5x minus 2x, that's 3x, equals negative 1 minus 3, that's negative 4. So x is negative 4 over 3. And then for this one, let's go ahead and distribute the negative on the right side. And then let's transpose. 5x plus 2x, that's 7x, equals 1 minus 3, which is negative 2. And so x is negative 2 over 7. So we have two values for x. But of course, we need to check them to make sure that they both work in the original equation. So let's take the negative 4/3, plug that in. And if you have a calculator using, it would be quicker. You don't have to write all this out when you're doing your check. So this is negative 20 over 3 plus 3. This is negative 8 over 3 minus 1. And then this is going to give me negative 11 over 3 in the modulus. And this is going to give me negative 11 over 3 in the modulus. And you can see that this works. The modulus of negative 11 over 3 is obviously equal to the modulus of negative 11 over 3. So that one works. Let's test the other one. So we're going to take the negative 2/7 and plug it into the original equation for x. And that gives me here negative 10 over 7 plus 3 in the modulus. And this is negative 4 over 7 minus 1, which is going to give me, this looks like 11 over 7 in the modulus. And this is going to give me negative 11 over 7 in the modulus. Now the modulus of 11 over 7 is 11 over 7. And we know the modulus of negative 11 over 7 is also 11 over 7. So both values work and both are solutions to this equation.